Welcome to this explainer. Today we're going to completely, fundamentally shift how you approach your physics papers. Seriously, if you're taking the Cambridge Physics 0625 exam, or frankly any of the related syllabuses like 0651, 0652, 5054, or even 9702, you probably already know the harsh truth. Just memorizing the textbook? Yeah, that's simply not enough. It's just not. You can literally know every single formula by heart, backwards and forwards, and still walk out of that exam hall with a grade that is way, way below what you actually deserve. It's frustrating, right? Well, today we are going to fix that. We're going to build bulletproof arguments and decode the absolute exact strategies you need to master these exams. We're looking at a methodology drawn directly from application-first teaching, specifically focusing on how numbers and units appear in real systems, in actual calculations, and of course, in those tricky exam questions. We're going to transition your entire mindset from just rote memorization to application-first reasoning. So grab a notebook, get hyper-focused, because what we cover today is literally going to elevate your mark scheme potential. Let's dive in.
Okay, so here's our agenda for today. We've got 5 main parts. Number 1, the challenge. Number 2, the strategy reveal. Number 3, the transformation. Number 4, an interactive workshop. And finally, number 5, your final system. Let's jump right into part 1.
Section 1. The challenge. Flawed exam answers.
Let's start with a very real challenge. In the Cambridge exams, you're constantly presented with these scenarios that require super precise numbers and units to solve. But here's the biggest mistake students make, and you might be doing this too, treating numbers and units as just decorative elements. Just those annoying little letters and symbols you tack on to the end of an answer purely because your teacher told you to. But that's a trap. A strong approach to any physics problem should always begin with a simple question that makes the concept feel necessary in the real world. When you open up that exam paper and you see a massive complex question about fields or forces or particles, circuits or waves, your brain naturally wants to panic. It just wants to start writing formulas as fast as possible. But listen to me carefully. That is exactly what the examiners are hoping you won't do. Before jumping into the formal, rigid language of a Cambridge question, you must first mentally identify the real-world physical effect taking place. You have to ask yourself, what physical effect, measurement, or prediction actually depends on understanding these specific numbers and units? Only after you visualize that real-world physics should you introduce the formal language. Doing this makes you far less dependent on memorized wording and so much more capable of reasoning your way through totally unfamiliar exam questions. Think about it. If a question asks about the thermal expansion of a bridge, please don't just jump straight to the equation. Stop. Visualize the metal actually expanding. What is the physical effect there? Why do those numbers matter? Well, they matter because real-world engineering, public safety, and transport literally depend on them. That's the mindset shift we need.
Now let's look at 2 incredibly common types of flawed answers. We see this all the time. First, we have Alex. Now, Alex's strategy is basically to overload the answer with raw physics facts. Alex just dumps isolated information onto the page, clearly hoping the examiner will kind of sift through the noise, do the heavy lifting, and just find the marks somewhere in that mess. There is absolutely no cause and effect in Alex's answer. It's just a desperate brain dump. Then on the other side, we have Sam. Sam's answer rushes straight to the math. Sam completely ignores the specific requirements of the command words. Does the question say state? Does it say explain? Describe? Sam doesn't care. Sam just ignores it. Now here's the tragic part. Both of these students might actually understand the physics perfectly well in their heads, but both of them are losing massive amounts of marks on paper. Why? Because they aren't structuring their knowledge in a way that the Cambridge mark scheme actually rewards. They're playing the wrong game.
Moving on to Section 2, Strategy Reveal, the Peel Framework.
To fix these incredibly common errors made by students like Alex and Sam, we need a really robust strategy. We need a system that systematically moves you from just everyday, casual language right into precise, mark-scoring physics vocabulary. Look, it's not enough to just know the answer inside your head. You have to essentially prove to the examiner exactly how you got there. The core principle here is that a strong explanation should move gradually. You begin with the concrete example, you use a symbolic relationship or a clear definition, and then you provide a fully worked explanation. And this leads us directly to the framework that takes your scattered knowledge and turns it into a laser-focused, high-scoring argument. Top students use this specific 4-step walkthrough to guarantee they show both profound understanding and practical application. We call it the Peel framework, specifically adapted for physics. Point, evidence, explanation, link. Let's break it down. Step 1, point. Identify the quantity or phenomenon. What exactly are we dealing with here? Is it voltage? Is it kinetic energy? Just state it. Step 2, evidence. State the relationship involved. This is exactly where your definitions and your equations come in. Step 3, explanation. Explain the underlying physics. This is the why. Why does this relationship even exist? And finally, step 4, link. Connect it back to an observation, an experiment, or a real device. The absolute safest method in any exam answer is definition, relationship, explanation, application. If you follow this exact chain, you leave the examiner absolutely no choice but to award you full marks. It's brilliant.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 3. Transformation red pens to green checks. So it's one thing to just know the four-step theory, right? It is entirely another thing to actually execute it under the pressure of a ticking clock in an exam hall. So let's build this out in reality. We're going to take those red pen marks that Alex and Sam got and methodically turn them into green check marks. Examiners actually have a secret playbook, and this table breaks down exactly what they hate seeing alongside the safest methods to fix it. Let's look at the first major weakness, writing the correct formula without explaining the variables. If you just slap F equals MA on the page, sure, you might get a single mark, but to secure all the explanation marks, you must define the specific variables in the context of the question. Whose mass? What acceleration? Second weakness, quoting a process without linking it to a physical effect. You literally cannot just say convection happens and expect full credit. You must explicitly link it to a physical change. You have to say the fluid expands, it becomes less dense, and therefore it rises. See the difference? And the third major weakness, giving an example without showing why it actually follows from the physics. You must justify the link using a clear, logical cause and effect chain. This is exactly what we mean when we say you need to structure your reasoning. No more isolated facts.
By simply shifting your mindset from a flawed, memorized formula drop over to a complete cause and effect chain, those red pen marks instantly turn into green check marks. It's honestly like magic. Instead of just throwing an equation at the paper and crossing your fingers hoping for the best, you systematically state the quantity, you give the relationship, you explain the physics, and you connect it directly to the real-world observation. And hey, if the topic involves graphs, for instance, you don't just read a number off the axis, you stress what the slope, the area, the direction, or the shape means physically. You're moving from just dropping isolated facts to building a cohesive, bulletproof physical argument.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at AceTheExams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to AceTheExams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Interactive Workshop. Test your application.
All right, it's time to put this into practice with a rapid-fire workshop. We're focusing on how numbers and units appear in real engineering, experimental systems, medical technology, you name it. Remember, you should always be able to name at least one real situation where the concept matters. So here is challenge number 1. You have 60 seconds on the clock. I want you to pause this explainer, scan the complex data source on your screen right now, and mentally extract the core physical trend. Do not just look at the numbers as abstract math. Ask yourself, what is physically happening here? Is energy being dissipated into the surroundings? Is the acceleration decreasing over time? Remember, if you're looking at a graph, what does the area under that line physically represent in the real world? Take those 60 seconds to find the physical reality behind the data. Go ahead, pause and try it.
Okay, hopefully you gave that a shot. Let's move to our second challenge, find the flaw. I want you to look at this sample paragraph on screen and pause the explainer again. Try to spot the exact sentence where the student gave a decent real-world example, but completely failed to show why the physics actually helps predict the outcome. It's a subtle trap, but examiners spot it immediately. For example, maybe they mention a car's crumple zone, which is great, but where did they fail to link it back to the increase in collision time and the subsequent decrease in average force? Finding these missing links in sample answers is the best way to train your brain to never, ever omit them in your own exams.
Keep this golden rule from the official examiner commentary in mind. Insist on cause and effect rather than isolated facts. That is the secret to the entire exam. Now we are going to transition into our third challenge, a 30-second speed writing challenge. I want you to try writing one absolutely perfect Peel paragraph. Point, evidence, explanation, link. Remember, every single sentence must cause the next one. Fact A causes physics B, which results in observation C. It is an unbreakable chain.
Section 5. Final System. Your Physics Success Blueprint.
All right, let's recap the ultimate answering system. This is the blueprint that will virtually guarantee you hit your target grade on exam day.
By keeping every microtopic tightly connected to both classroom reasoning and the exam structure, you totally eliminate the guesswork. These 3 fundamental rules form your absolute safety net. Rule number 1, command word decoding. Never start writing until you know exactly what words like describe, explain, or calculate are actually demanding from you. Rule number 2, Peel framework application. Use point, evidence, explanation, and link to structure your cause and effect chain. Always move from everyday language to precise physics vocabulary. And rule number 3, the time management matrix. Please do not spend 10 minutes on a simple 2-mark isolated fact question, and conversely, don't rush through a complex 6-mark explanation question. Allocate your time strictly based on the depth of the cause and effect chain that's required.
To lock all of this in, make sure to ask yourself these 4 core revision prompts out loud during your study sessions. 1. What is the core idea? 2. What changes physically in the real world? 3. What specific quantity or graph mathematically shows this physical change? And 4. Where is it used in real life? Engineering? Astronomy? If you can answer those 4 prompts aloud, your memory is locked in for both short answer and structured questions.
Now, the numbers absolutely do not lie. Students who consistently implement these specific physics strategies, shifting from just rote memorization to this application-first, cause and effect reasoning, see an average improvement of a massive 2 grade boundaries. 2 whole boundaries. But listen, that only happens if they practice consistently with our weekly explainers and apply it to every past paper they do.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams. Add @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.